All right, so we've converted polar coordinates and rectangular coordinates back and forth with each other. Now we're going to look at polar and rectangular equations and how we can convert those back and forth. A couple of things that we need to define before we do that. The first thing is that x is equal to our cosine. Remember, we did that when we converted coordinates, and that y is equal to our sine, and that x squared plus y squared equals r squared. That was that Pythagorean theorem that we talked about, but in terms of x squared, y squared, and r squared. So to convert from a rectangular coordinate or rectangular equation to polar equation, we're going to use those three tools, those three definitions, and then we're going to solve for r or r squared, depending on the problem. All right, so let's look at example 1. So it says 3x minus 6y plus 2 equals 0. So we're going to switch x to our cosine. So 3 times our cosine theta minus 6 times our sine theta plus 2 equals 0. So now we need to get r by itself. We'll subtract 2 from both sides. So 3r cosine theta minus 6r sine theta equals negative 2. And now we can factor out an r because both terms have an r in them. So r times 3 cosine theta minus 6 sine theta equals negative 2. Okay, and then to get r by itself, we'll divide both sides by what's in the parenthesis right there. 3 cosine theta minus 6 sine theta. So r is equal to negative 2 over 3 cosine theta minus 6 sine theta. And we've gotten our r by itself now, so that is our final answer. As ugly as that looks, that is as far as we can go with this. Now with letter B, we're going to replace x with our cosine theta equals 4. Then divide both sides by the cosine of theta, so r is equal to 4 over the cosine of theta, which we can simplify a little bit further. We couldn't simplify in this one because we had a subtraction sign in the denominator, but because we just have a single trig function here, r is going to be equal to 4 secant theta, because 1 over cosine is secant. We can make that switch, and that would be our answer. Then letter C, we have x squared plus y squared minus 2ay equals 0. Well, x squared plus y squared is equal to r squared minus that y is equal to r sine, so minus 2ar sine theta equals 0. So we can factor out an r because both terms have an r. We have r squared and r to the first power. So r, and then we're left with r minus 2a sine theta equals 0. Now, normally we would never want to divide by a variable, but in this instance, in these problems, sometimes we don't have a choice. So we're actually going to divide both sides by r because that will get rid of an r. Now, when we do that, though, we have to emphasize that r cannot be 0 because we would be dividing by that. So we're going to say r cannot equal 0. So then we're left with r minus 2a sine theta equals 0. Well, we're going to add 2a sine theta to both sides. So then we get r is equal to 2a sine of theta. And again, we say that r cannot equal 0 because we divided by r right here. So this would be our final answer. All right, then letter D, we have x squared equals y to the third power. Now, you might be tempted to try to make this x squared plus y squared because we can replace that with r squared. But if we subtract y squared or y to the third power from both sides, then we have a subtraction sign. So that's not going to help us. So what we'll do is switch this to r cosine theta squared equals r sine theta cubed. Okay, so then we're going to get everything to one side because then we can maybe factor out the r. So we're going to do r cosine theta squared minus r sine theta cubed equals 0. Now we're going to distribute the square to the r and the trig function, the cosine. So r squared times cosine squared of theta minus, distribute the third power, r to the third times sine cubed of theta equals 0. We're going to factor out an r squared. So when we factor out an r squared, we're left with cosine squared theta minus r sine cubed theta equals 0. And just like in the other problem, we're going to divide by r squared because those cancel. And then we say, r squared can't equal 0. All right, so now this leaves us with cosine squared theta minus r sine cubed theta equals 0. All right, so we're going to add the r sine cubed to the other side. So cosine squared theta equals r sine cubed theta. And then we're going to divide both sides by sine cubed theta. Divide by sine cubed theta. So that's going to give us r equals cosine squared theta. And I'm going to break up that sine cubed to sine squared times sine to the first power, because now we can make this into cotangent squared, and then 1 over sine becomes cosecant. So then we get r is equal to cotangent squared theta times cosecant theta. And again, r squared cannot equal 0 because that's what we divided by. So the process isn't difficult. You just have to remember your conversions from up here, and then just simplifying as far as you can go. All right, then letter E, y squared equals 5 minus x squared. If we add x squared to both sides, well, x squared plus y squared is the same as y squared plus x squared. So r squared is equal to 5, which is something we're allowed to do. We said up here that we need to get r or r squared by itself. So this is an acceptable answer. All right, now on the next page, we're going to go in the opposite direction. So we're going to go from our polar equation into rectangular form. And we're still going to be using these definitions, but going backwards. So letter A, r equals 4 sine theta. Well, we need to have r sine theta so that we can replace it with y, or r squared so we can replace that with x squared plus y squared. So what we're going to do is we're going to multiply both sides by r times r times r. What that will do is give you r squared equals 4r sine theta. And r squared is equal to x squared plus y squared. And that equals 4. And then r sine is equal to y. So you can leave it like that, but we want these to equal 0 if we can. Like up here, how some of them equal 0. If we subtract 4y from both sides, so x squared plus y squared minus 4y equals 0, that's more of a precise equation. So if you can, we want to do that. So example 2, we have r equals 4. Well, you may say, well, let's multiply both sides by r so we get r squared on the left side. But if we multiply both sides by r, then it's going to be r squared equals 4r. Well, we can't have an r or anything, or an r squared, or r to any power, or any trig function in our rectangular form. So instead, we're going to square both sides. So this is going to become r squared equals 16. Well, r squared is x squared plus y squared equals 16. And then if we subtract 16 from both sides, x squared plus y squared minus 16 is going to equal 0. All right, letter C looks a little bit different. We have theta equals pi over 6. Well, we don't have any trig functions. We don't have r. We just have theta is equal to pi over 6. But we need to get this in terms of x and y. So what we can do is say that the tangent of theta, which is equal to y over x, now we can substitute what theta is equal to. It's equal to pi over 6. So the tangent of pi over 6 equals y over x. Well, we know that the tangent of pi over 6, because it's in the pi over 6 family, the tangent of that is going to be the square root of 3 over 3. That equals y over x. So then we can cross multiply. So that's going to give us square root of 3 times x equals 3y. And then we can divide both sides by 3. And then we'll get everything over to one side. So I'm going to make y positive. So then 3y minus the square root of 3x equals 0. Now, if you wanted to, you could divide everything by 3 to make it a single y variable, but that's not required. So we can leave it just like that. All right, letter D, r is equal to 5 cosecant theta. So r is equal to 5 over sine theta. So from here, we can cross multiply. This is really over 1. And when we cross multiply, we have r sine theta equals 5. Well, again, r sine theta is equal to y. So y is equal to 5. And if we subtract 5 from both sides, y minus 5 equals 0. So the hardest part about these problems is coming up with a strategy on how you can eliminate your trig functions or the r values. The first one we did, we multiply both sides by r because we know that if we have r squared, that changes to x squared plus y squared, and if we have r sine, that changes to y. So that's why we approached it that way by multiplying both sides by r. But in letter B, that strategy wouldn't have worked, so we squared both sides instead. And then letter C, all right, we said, okay, what do we do with this? We need x and y in our answer, so we said, okay, the tangent is y over x, and then we can replace theta and simplify it. And then here we had to cross multiply to get that r and sine together. All right, now letter E seems a lot more difficult than it is. We're going to cross multiply. And when we cross multiply, remember this r is going to be multiplied by both things in that denominator. So we can distribute. So you have 3r sine theta minus 5r cosine theta equals 8. Well, again, r sine theta is equal to y. So we have 3y minus, oops, I didn't want to highlight the 5. Our cosine is x, so minus 5x equals 8. And then we subtract 8 from both sides, and we get 3y minus 5x minus 8 equals 0. Again, it wasn't that difficult to do. It didn't have a lot of steps, but you had to look at this and approach it that way in order to get the answer. All right, now our last one, r equals 1 over 1 minus sine theta. So we're going to cross multiply this one again. So we get r times 1 minus sine theta is equal to 1. So we can distribute this, so we get r minus r sine theta equals 1. Well, the r sine theta, that is equal to y, so r minus y is equal to 1. Then we can add y to both sides. R equals 1 plus y. Then at this point, we look at that and say, well, how do we get rid of this r? Well, up here, there was 2 ways we got rid of r when it was r equals something. We multiplied both sides by r, or we squared both sides. Multiplying both sides by r is not going to help us because then we would have an r on the right side. So we're going to square both sides. So that's going to be r squared equals 1 plus y squared if we use the shortcut, and maybe we'll rearrange this first so that we can see the shortcut easier. So r squared is equal to x squared plus y squared, and then y plus 1 squared using our shortcut is y squared plus 2y plus 1. Then we got to move everything to one side. I'm going to move everything over to the left. So subtracting y squared from both sides, then 2y, and then 1. The y squareds are going to cancel, so we're going to have x squared minus 2y minus 1 equals 0. So that would be our final answer. Okay. So I know that this looks very intimidating, but as soon as you know which way you want to approach it and use these definitions up here, it does become a lot easier, and it's going to be like those identities from chapter 5, where the more you see these, the easier it is. Just, you need to get r squared and convert that. R sine, R cosine, those are the things that we want to look out for. All right, so that's it for converting these equations. Thanks for watching. Make sure to like and subscribe.